The first time that I actually dove on Titanic, I was obviously nervous. I wasn't sure what to expect. It's not like every day that you jump into submersibles and are thrown overboard and go 2.5 kilometers below the surface of the ocean. So it's a little bit nerve-wracking at first.
Most of us know the story of the Titanic. In 1912, the massive, supposedly indestructible steamship sank after hitting an iceberg on its first and only journey across the Atlantic Ocean. Because of its tragic fate, there aren't that many people who have actually seen the ship. Ocean explorer and microbial ecologist Laurie Johnston is one of the few people who has.
When you actually see the bow with your own eyes through the porthole, it's breathtaking. You just sort of stare in awe at the ship itself, and it's huge, right? Pictures don't really do justice to the size. It's very surreal. It's beautiful in the fact that there are so many colors, which is odd to describe in a shipwreck, but the colors are phenomenal. They're orange and green and blue and yellow and purples, and it's just this huge rainbow of colors from the growth that is on the wreck itself. It doesn't feel ominous. It feels very serene. It's quite breathtaking. It's a lot to take in one go.
And Laurie hasn't had just one chance to visit the Titanic's wreckage. In fact, she's visited 6 times, and each time it looks a little bit different, because the ship that disappeared for more than 70 years after it sank might be disappearing yet again, this time for good. And the culprit is not another iceberg. This time, it's something much, much smaller. Welcome to Tiny Matters, a science podcast about the little things that have a big impact on society, past and present. I'm Sam Jones, and I'm joined by my co-host Deboki Chakravarti and journalist Lily Halloran, who interned with us this summer and did the reporting for this episode.
Hey guys, I'm happy to be here. And I was more than happy to spend my summer learning about the Titanic and other shipwrecks, and in particular, why they're disappearing, but why that might not be such a bad thing. To start, let's go back to Titanic's maiden voyage. On April 10th, 1912, the RMS Titanic left Southampton, England, headed for New York. But just 4 days later, the ship struck an enormous iceberg. At the time, Titanic was the largest ship ever to move on water, and it was advertised as practically unsinkable by its builders. But the Titanic was no match for the iceberg. In the early morning of April 15th, the unsinkable ship, sank.
Titanic remained undiscovered on the seafloor somewhere in the North Atlantic Ocean for 73 years, until Robert Ballard came along. In the early 1980s, the ocean explorer approached the United States Navy about his new deep-sea remote-operated vehicle that could help find the long-lost ocean liner. And the Navy said, "We don't really care about the famous shipwreck, but there are 2 nuclear submarines we're missing. So we'll give you funding to look for those, and then, if you have time left, you can go look for the Titanic." So, side note, wild and also a little bit disconcerting that nuclear submarines can just go missing.
Yeah, no, I don't like that.
Luckily, Ballard and his team were able to find them, which is good news for my nerves, and it was also good news for Titanic enthusiasts. Because in September 1985, they found the ship, which was over 2 miles underwater.
So it has now been about 40 years since Titanic was first discovered. And since then, it's become even more infamous thanks to books, documentaries, and the very culturally important 1997 film epic Titanic with Leonardo DiCaprio and Kate Winslet.
Lily, I had a truly, truly harrowing moment with you while you were working on this episode where I learned that you did not grow up with the same formative experience I did of going to watch Titanic in movie theaters. And I know it's because you're younger. Time just passes on. But I hope Sam also appreciates just how shocking this was, because I remember the Titanic as being like this huge moment.
Yeah, I mean, Titanic, not just Leo DiCaprio at its finest, in every sense of the word. It was this huge movie. And although we were very young when it came out, like, I don't know if my parents let me see it in movie theaters because of...
I saw it in movie theaters next to my mom and my aunt, and it was mortifying.
Yeah. But by the time I was in my late teens, I think I'd seen it like more than a dozen times. And then I've probably seen it a dozen times since then.
I'm kind of scared to say it, but the movie is, in fact, 6 years older than me.
We're so old. We're so old.
I know.
But considering how important it was to you both, I have what may be bad news.
Tell us.
You know that famous scene in the movie where Jack tells Rose to step onto the ship's railing and she goes, "I'm flying, Jack."
Of course.
Well, on the last visit to the wreckage in summer 2024, remote operated vehicles took millions of pictures of the wreck and revealed that very railing, immortalized in the movie scene, collapsed onto the seafloor sometime in the last 2 years.
I had never really thought about the railing in that scene like being a real thing, but it's sad. That's sad. It's collapsed now.
I know. If Jack and Rose were real people, I'm sure they would be devastated.
Well, because the Titanic went undiscovered for so long, researchers were only able to start studying the ship's deterioration in the last few decades. And they found that one of the main reasons Titanic is disappearing is bacteria.
I mean, obviously, it would be best not to have your ship at the bottom of the ocean. But if it does happen to, it does create an opportunity. And biological organisms are all about opportunism to create life around there. So immediately, bacteria in the natural ocean would have began to colonize and feast on what is now at the bottom of the ocean.
And what those bacteria had to eat was a gigantic ship. And sure, they could eat the food from the fridges, but also they could eat the ship itself, which we know they've been doing thanks to the presence of rusticles, a telltale sign of decay.
So a rusticle is basically exactly what it sounds like. They look exactly like icicles, except they have more of this rust, this reddish orange kind of color to them. And that's very unique.
That's Erin Field, a marine microbiologist and professor at East Carolina University who studies some of the bacteria that form rusticles. You might normally see rust on things like your car. It shows up on metal objects that have iron in them because when iron reacts with oxygen and water, it gets oxidized, which forms rust. And underwater, that rust can pile up into rusticles that range from microscopic to up to 15 feet in length. Erin told us they can form in a couple ways, like through chemical corrosion, if the pH and other conditions are right. But microbes can also make rusticles by basically eating away at the iron on the shipwreck.
Really what they're doing is just gaining energy through that process. By producing rust, which is what we visibly see, the microbes have gained an electron and energy that allows them to live and grow.
But rusticles aren't just made up of rust. There are other ingredients like sand, sediment, chemical waste products, and some microbes who just like to be around the action.
And what I think is really cool about the rusticles is that they're not really static. So meaning if we have photos of a wreck and then we go back months or years later, they can look different. So they are changing, much like icicles on a house will melt and reform. Even though they're these mineralized forms, they still have kind of a living aspect to them, and they are changing. So I think that's super cool.
Erin told us that one species of bacteria found on a rusticle is actually named after the Titanic because it was first discovered on rusticles collected from the wreck.
So Halomonas titanicae is an amazing microbe that's been found associated with the Titanic. And in this case, what the organism does is it takes the rust that's produced and it actually uses it as an energy source to grow.
Halomonas titanicae gains energy, not much, but enough to stay alive, by transforming rusty, oxidized iron back into what's called reduced iron. And that's great news for a lot of organisms in the ocean because reduced iron is often limited in aquatic environments, particularly in the ocean.
Every organism is fighting over this small amount of iron that exists. And so when shipwrecks occur, we actually introduce a new source of iron because many of them are constructed out of metals, which have a high iron content.
To reference another culturally important movie from my childhood, it's like The Circle of Life, except it's really the circle of iron. There are the iron oxidizing bacteria that take iron from a shipwreck to create rust and eventually rusticles, and then there's Halomonas titanicae, which reverses the whole process, turning rust back into soluble iron.
That means that another organism can use that. It's biologically available, or it could even just disappear in the water column when the currents pick up. So now we start to see the iron is no longer associated with the wreck itself.
So these bacteria and their little circle of iron are causing shipwrecks like the Titanic to fall apart.
And for the record, I have seen The Lion King, and it was a favorite growing up.
We're both so relieved to hear that.
Good.
You may have heard of Halomonas titanicae because lots of news articles have cited it as the reason why the ship is decaying. That isn't wrong, but Lori says it's not the entire truth.
It was one of the bacteria that were found down there. Lots of people think, well, that's the dominant bacteria. That has to be. That's what it's named for. But bacteria don't work that way in nature. It's a consortium bacteria. And probably we've found, is it molds? Is it fungi? Is it all sorts of different things that work together in order to be able to use the Titanic as their home, as their food source, as their energy sources. So no bacteria alone will be able to do it.
Other news outlets have reported the ship will collapse by 2050 or even 2030, based on predictions made when scientists first started studying the Titanic's decay. But Lori says that we still have a lot to learn about the bacteria and their activity before we can make that kind of prediction.
What we have sort of determined over time is that there was a period of time where the bacteria are sort of getting settled in and deciding where they're going and what is the best area for them for that type of consortium. And then they start to ramp up. And as they ramp up, we're in a period right now where they're very aggressive and they have done a lot of deterioration of the wreck itself. So they have claimed it as their own. Now, it's still a wreck, and it'll probably be a couple hundred years before it becomes a rusty smudge on the floor.
That said, it is disappearing a lot faster than anyone really anticipated.
Everyone thought that, hey, this would stick around for a while, but it isn't. And we're really trying to understand the processes that are contributing to the rapid deterioration.
That's Erin again. She told us that sometimes you'll see one area of the shipwreck deteriorate faster than others, which could be due to different construction materials or other factors. For example, the National Oceanic and Atmospheric Association has estimated the stern of the Titanic is decaying 40 years faster than the bow.
Part of the work we're doing is trying to understand why are some areas deteriorating more rapidly than others, and what can we do to stop that? The Titanic has so much history and so much importance that we really want to understand why this is happening.
As archaeologists studied shipwrecks, they eventually realized they'd need help from biologists to understand the living communities that were moving in. They wanted to know who the microbes were, why they were colonizing these wrecks, and how they were impacting the remains. And as these scientists started working together, a new field emerged called maritime heritage ecology, with the goal of studying the underwater interactions between archaeology and biology. And this probably doesn't come as a surprise, but a lot of these studies have to take place on a boat.
I've been seasick enough in my career that I have often sat in my bunk suffering, wondering, why did I choose this life? I could have been a baker, I could have been a veterinarian, raised cats, what have you. But it always ends just having your mind focused on doing science instead of your mortality and your bodily suffering.
That's Layla Hamden, a marine microbial ecologist and professor at the University of Southern Mississippi.
The focus of my work always has been paying attention to microbes, listening to what they have to say about the world around them, and tuning our analytical ears to the knowledge and the messages that they're sending us.
The idea of using microbes for their knowledge has led Layla on lots of seasick-inducing cruises on all oceans of the world. And in the last decade, it's led her to shipwrecks.
One of her formative experiences in the field was after the Deepwater Horizon spill in 2010. Since there are an estimated 4,000 shipwrecks in the Gulf of Mexico, Layla and her colleagues wondered how oil was affecting the wrecks near the spill. Archaeologists knew where the wrecks were, and Layla knew where the microbes were. So they put the two pieces together and discovered that metal shipwrecks in the fallout zone were corroding up to 9 times faster than similar wrecks in other places, all because microbes were interacting with the oil and producing chemicals that corrode steel. And putting archaeologists and biologists side by side on a project can emphasize just how differently they see the world.
We took the ROV over a World War II historic shipwreck, a German U-boat that's broken up into a couple of pieces in the Gulf of Mexico. And as we moved from one part of the site to the next, my colleague said, "Did you see that flight jacket? Did you see that boot? Did you see all of these artifacts, that are associated with human activities?" And I said, "No, I was looking at the shrimp that was running across the seafloor with some kind of food substrate in its mouth, and I was just fascinated with what is this guy eating."
Layla was seeing animals like shrimp because shipwrecks aren't just a place of decay. They can also transform into something new, an artificial reef.
An artificial reef, it's a somewhat loose term, but we can think of it as any non-naturally occurring hard material that ends up on the seafloor. And when it's there, it has the potential to encourage biological life to grow on it. When you have a hard substrate on the seafloor, it means that larger organisms, corals, tube worms, all other types of biological life has something hard for them to attach to, and then it could flourish with other types of life.
What an artificial reef looks like depends on where it is in the ocean. In shallow water with light, there may be corals and fish and small mollusks. Further down, you could find colorful tube worms and organisms that thrive in deep, dark, cold environments.
But one thing that is consistent, no matter where these locations are, is that the microbes showed up first. The first thing that happens when any kind of structure enters the marine environment is that it is instantaneously colonized by microbes.
As microorganisms colonize the surface of a shipwreck, or a container, or a washing machine, or whatever debris has ended up in the ocean, they create a sticky substance that encourages other small organisms to join in on the fun, forming what's called a biofilm. And as that biofilm gets denser and denser, larger organisms start to attach too, resulting in what Layla called an oasis of biodiversity on the seabed. Despite how important microbes are to understanding the formation of these artificial reefs, they're difficult to study, in part because they're just so hard to see. But studying them more closely may help answer questions from earlier in the episode, like, why is Titanic decaying faster than expected?
And I think that's one of the things that our work is really trying to get at, is trying to identify organisms that could be bioindicators. So looking at which ones can really help and promote protection, and then which ones are harming it.
That's marine microbiologist Erin again. She told us that some of the bacteria that attach early on to shipwrecks can be indicators of future decay, because they can set the scene for other more damaging bacteria to show up later.
And on the other hand, there are also bacteria that could help preserve shipwrecks. For example, a biofilm could act as a barrier from the seawater, which would protect the surface of the wreck from chemical corrosion. Understanding microbial communities on artificial reefs is difficult, though, because there are tons of factors that influence which bacteria are present and which aren't. Things like light, water temperature, currents, even the size of the grains of sand in an area.
Every wreck is its own unique story, its own unique kind of living, breathing thing, even though it's a ship. And I think thinking about it from that perspective, we don't expect that every wreck has the same microbes. But if we can find trends or we can identify patterns, then we can really start to get out how do we preserve them and make sure that we're conserving them.
From a historical perspective, it may be important to conserve Titanic and other shipwrecks because they represent pieces of human history. But on the other hand, Titanic is being put to good use.
From a biological perspective, they really are important because they represent habitats in the form of artificial reefs. And really, all of these wrecks are becoming important because as we're losing our natural reefs, we really are relying more heavily on artificial reefs.
In some cases, materials are placed intentionally on the seafloor to become artificial reefs. That's how dire the need for them is. Some estimate there are almost 2,000 intentionally sunk shipwrecks across the world.
So we're really trying to understand the long-term effects of these wrecks as artificial reefs. And I think that work is coming along really nicely. I think that we still have a lot to learn about them, but as we lose our natural reefs, we do need another option. And it does support the fish, it does support tourism, and a lot of things that can benefit the local communities.
In 2006, the USS Oriskany was the first ever shipwreck intentionally scuttled in the United States for this purpose. After 25 years of service, the US Navy and the Florida Fish and Wildlife Conservation detonated explosives on the ship, sending it to the sea floor. Now it's the largest artificial reef in US coastal waters, and a big spot for ecotourism. But that's a challenge too, because Aaron and others think that people physically touching shipwrecks may be speeding up their decay.
You could be removing biofilm that's protecting it. You could be introducing microbes that weren't there before. I don't think people go in with the thought that they're trying to do that. They just are excited to see it and they want to touch it and really interact with it, especially in shallow water wrecks. But it can have a harmful effect. Similarly, sunblocks or anything else somebody is wearing when they go in, that could potentially harm them as well. Biofilms sometimes are really attached, but sometimes they're very loosely associated and they're constantly changing.
On the USS Oriskany, decay is probably less important. I mean, they intentionally sent that one to the seafloor. But on ships like Titanic, which has been designated by UNESCO as a marine cultural heritage site, more human visits is probably something to be cautious about.
When they were doing tourist dives and that sort of thing, if anything sort of hits the ship, it is very fragile. It's been under the ocean for a very long time, and those bacteria have had their heyday with the wreck. So there are signs of damage, of human damage to it that are quite visible.
Lori told us that landing a submersible or remote operated vehicle on the wreck would significantly harm the ship. She's even skeptical of missions to bring back artifacts from the Titanic's wreckage, like a proposed plot to rescue the equipment that sent the final distress signals.
My personal feeling is don't touch. Leave it alone. I think it's beautiful. I think that the deterioration is beautiful. I think it has so much for us to learn as far as understanding that Titanic and the wreck of Titanic was really brought on by the arrogance of man. The microbes and the organic life down there have definitely taken it over. And it's not ours, but everybody has their own take on it. And mine just happens to be on the side of the microbes.
Layla thinks it's crucial to keep studying the estimated 3 million shipwrecks scattered across the world's oceans, because they represent some of the first examples of human-placed infrastructure at sea. Today, we have thousands of kilometers of pipelines and oil and gas platforms, and their effect on sea life is still largely unknown.
We study the shipwrecks because they are these exciting glimpses into this beautiful life on the seabed. But they're also debris. They're also built infrastructure, and they, in and of themselves, even if it looks beautiful and like a Disney movie with, all of the color and the, the biological scape, they're still changing the seafloor. And it's maybe in a way that's irreversible. Perhaps it is reversible. And maybe there's a tipping point of how much reef is good before it turns into too much on the seabed. And, I think that that's relatable to everybody, that everything that you do, every purchase that you make at some point may have an impact on the seafloor if it eventually ends out into these deep, dark, and remote environments that we consider, the great frontier and the untouched wild, but they're not.
Should we tiny show and tell?
I think we should.
Do one of you want to go first?
Okay, I'll go. My tiny show and tell is kind of in theme with our episode in that it's like about old stuff and how to study old stuff. But like this is going to be super, super old stuff. We're going to talk about like millions of years old because obviously like scientists want to study fossils and like they want to learn about things that go back a long, long time ago, like before humans ever existed. And one way they can do that is by looking at DNA sequences, but that takes us about like 1 to 2 million years ago because DNA degrades over time. So another thing that they can look at are proteins, except proteins also degrade. And so for a while, the furthest back that scientists had been able to go was about 3.5 million years ago, looking at a collagen sample that came from a fossil that was from a relative of the camel that lived in the Canadian Arctic. Like, that already, I was like, what? But that's not the point of today. Today, what I want to talk about is the fact that 2 separate groups of scientists have been able to push back that date even further by looking at teeth. So one of the groups was looking at fossils of extinct rhino, elephant, and hippo species that went back like 1.5 to 18 million years ago in the Turkana Basin in Kenya. And that's really impressive because that area is super hot. So it's really hard to preserve proteins there. But they were able to get proteins from the enamel of the teeth. Another group looked at fossils in like super northern Canada. And they were able to get a read on a protein that would have been around 24 million years old. So that's even older. And it's a little bit easier because it's cold. Like that's part of why they were able to go so far back. And so the basic idea for why this might have been able to work for these groups is that the enamel of teeth might be really good at helping to preserve proteins. And so this might serve as a way to help scientists in the future study really, really old fossils and really, really old proteins.
That's really cool. And we also have an episode that very much talks about teeth. And I feel like we've talked about enamel at various points.
We've talked about teeth recently. Yeah.
Yeah. There have been like some...
You had like a few tiny show and tells that were about like flossing. And I remember being feeling attacked. And now people in the future, millions of years from now, will be able to look at the proteins in our enamel. Maybe not my enamel. My enamel will be gone. But someone's enamel will be able to tell people in the future about us.
My tiny show and tell, I saw there were a couple of very recent news stories about dogs, and I was like, well, I'm going to mention both of them. So the first one, we've talked about dogs and their unbelievable scent detection capabilities before in terms of bomb sniffing, in terms of potentially sniffing out disease. So there are 2 studies that have come out, one in the US and one at the University of Bristol. The one in Bristol looked at dogs detecting Parkinson's years before symptoms come up. It's an 80% sensitivity and 98% specificity. In terms of the sensitivity, I guess there were other health conditions that sometimes people had. And so they were like picking up on something, but being able to actually detect if someone did or did not have a scent that they were giving off that would either say they had or would soon have Parkinson's. It was a 98% specificity for that. So we're learning more and more about how dogs can detect certain scents that like odor molecules, like compounds that the body would produce under certain disease conditions and start producing before the real disease symptoms set in. And I think that's very cool because a lot of times with, addressing a disease like Parkinson's, there are drugs that are available that can really lessen symptoms. And so if someone knew that they were really at risk or potentially were going to develop something within a few years, if you could preemptively get on a medication to really slow that down, I mean, that could be life-changing. So I thought that was great. So that's a win for dogs. Another win for dogs is that then the day after this study came out of Virginia Tech showing that dogs can actually sniff out an invasive insect. Have you heard of or seen things about the spotted lanternfly?
Yeah. Oh, yeah.
The spotted lanternfly sucks. It's invasive. It's damaging farms and forests, mainly across the eastern and I guess also central United States. But at Virginia Tech, they have trained dogs to actually detect the egg masses of these spotted lanternflies, which I guess are very, they say, elusive in the press release. But I guess it's really hard to find these egg masses. And right, like once these spotted lanternflies are hatched, it's hard to control them. But if you can actually kill them before they hatch, then that could really help protect farms and forests. And yeah, these things are nasty. There's a bunch of them out right now, right around where I live. I step on them. So this is a dog appreciation show and tell.
Yeah, and also a spotted lanternfly anti-appreciation. Almost,
Yeah.
We've put out the challenge to find someone who was Team Wasp, and we got a few takers. So if there's anyone who's Team
Spotted lanternfly, I mean, sure, come challenge me, but I have things to say.
Well, Sam, I'm really glad that you brought up dogs because my tiny show and tell is also about animals, and dogs and this animal compete for the top spot for my favorite animal all the time.
Ooh.
And mine is about penguins,
Oh.
specifically Magellanic penguins. So these are penguins that are found off the coast of South America, and they have these like really distinctive stripes around their chest and their head that look kind of like they're wearing headbands.
I've seen photos of these.
Well, researchers just recently discovered that these penguins use tidal currents to navigate and save energy. They're well known for traveling really far to forage food for their chicks, like 75 to 100 kilometers out. And the researchers wanted to know how they were finding their way back to the colony after they go so far away. So they put GPS on 27 Magellanic penguins, and they found that if the waters were calm, the penguins would maintain that straight path back home. But if the currents were stronger, they would adjust their path to align with the lateral flows of the current. And what this means is that their return paths often ended up being like S-shaped. And that was kind of cool and counterintuitive for me because you often hear that's like the straightest path is the best path. But for them, the windier path actually reduced how much energy they spent.
Huh.
Yeah, so the researchers calculated something called ease of transport, which is essentially how many meters they travel per joule of energy. And they found that the penguins achieved higher ease of transport by using the current-driven S-shaped paths compared to if they just tried to fight the currents and swim directly to the colony. They do kind of look like they're surfing a little bit. Like it looks really fun. Anyway, I love penguins and I think this makes them sound really smart.
I love that. That's so fun.
I always love hearing about penguin journeys. They have to go so far.
It's unbelievable.
Yeah.
It's amazing. And they like find each other again. It's very sweet. Thanks, Lily.
Yeah.
And thanks for taking part.
This is like a dream come true.
Thanks for tuning in to this week's episode of Tiny Matters, a podcast brought to you by the American Chemical Society and produced by Multitude. This week's script was written by Lily Halloran and edited by me, Michael David, and Sam Jones, who is also our exec producer. It was fact-checked by Michelle Boucher. Our audio editor was Lily Halloran. The Tiny Matters theme is by Michael Simonelli and the Charts and Leisure team.
Thanks so much to Lori Johnston, Erin Field, Layla Hamden, and, of course, Lily Halloran for joining us. We'll see you next time.